So now we're going to talk about these other indeterminate forms that we haven't talked about. So it's these all involve exponents, so 1 to the infinity, infinity to the 0, and 0 to the 0. All of these, again, are indeterminate forms, so you cannot determine the limit straight from these. So let's look at an example. Let's evaluate the limit as x goes to infinity, 1 plus 1 over x to the x. So if I look at the inside, 1 plus 1 over x, as x goes to infinity, that's going to get closer to 1. And then my power, my exponent, would be infinity. So 1 to the infinity, I've been writing that in blue, I'll write it in blue, 1 to the infinity, that's an indeterminate form. And so really the problem here is the exponent, and it's kind of an obstacle in calculating this limit. So we're going to let y equal this limit. And I would really like for that exponent not to be there. And so one thing I know is that properties of natural logs let me bring exponents down. So what I'm going to do is I'm going to take the natural log of both sides of this equation. And then I can interchange, because the natural log is a continuous function, I can switch the order there. And now, because of properties of logs, I can pull this exponent down in front here. So this will give me the limit as x goes to infinity, x times ln 1 plus 1 over x. And if I look right now at my limit, here, this x is going to go to infinity. And then the inside of 1 plus 1 over x is 1, and ln of 1 is 0. So I'm getting infinity over 0. And remember, we had something like this in our last video. We've got to rewrite it as a fraction. So really the only thing for me to do is put this x right here, put it in the denominator as a 1 over x. And now I'm going to get, well, this is still 0, and this is now 0 too. So I have 0 over 0, which means I can use L'Hopital's rule now. Here, the limit as x goes to infinity, you got to take the derivative of this. The derivative of that is 1 over 1 plus 1 over x times the derivative of 1 over x. Got to use the chain rule here. The derivative of 1 over x, it's a negative 1 over x squared. So these two things are going to cancel. And now I'm looking at the limit as x goes to infinity, 1 over 1 plus 1 over x, which is 1. Now this isn't actually what I wanted to find. If you remember, this is ln of y. So then y must be e. And that's what my limit is equal to. It's equal to e. So anytime you have one of those indeterminate forms where you have an exponent, you're going to use this trick where you take natural log, which allows you to remove the exponent, and then you can use L'Hopital's rule.